Hey guys, welcome to my channel. In this episode, I would like to build a rocket stove. It will be not the 100% correctly because it will be made out of steel, so the efficiency will not be as good as it should be. There will be no isolation and other things that are improving performance, and also the dimensions will not be exact, just because the steel that I have and the tools that I have to make it as accurate as possible. But I've seen quite a lot of videos on YouTube where people call the stoves that they did as a rocket stove, and that not every stove is a rocket stove. So let me show you how I plan to do this. So it will be very small. First, that piece will be a chimney. It is 8 by 8, around in centimeters, 4 millimeters thickness, and around 58 centimeters height. Steel isn't a good material for the rocket stove because the heat that rocket stoves produce is distracting the structure of the steel, so it will get rusty very fast. But that's just for my test purposes and also for the welding practice, so it is good enough. So that's the chimney. I didn't have a big enough profile for a burning chamber, so I took 10 by 10 and I cut it half. Now I have a 4 centimeter length piece of steel. I don't know, you call it probably a coupon or something like this. So the goal is to weld it like this, yeah, and have higher profile of the burning chamber. Then I had also I couldn't find a correct C profile in my store, so I took the full profile and I cut it half also, more or less half, yeah, something like this. So that's not the perfect because I had to cut it using my grinder, but I guess I can correct it during welding, and that will be welded on the top of the burning chamber, and it should provide extra air, already a little bit heated, directly to something which is called port. There will be another piece going down. And here there will be a burning chamber. Here will be something what is called in documentation as a port. So also 2 coupons, I guess, around 20 and a half centimeters height and 5 centimeters width at the bottom, and I need to weld it like this, and that will be called port. So here I have 5 centimeter piece of steel, here the same width but centimeter shorter, because that's where we want to provide this extra flow of air from the burning chamber. So it's not very complex. That was quite a bit of cutting those small pieces. Now I need to prepare them for welding. Weld them, and then I will show you how it works. Rocket stove is done. Yesterday, just after weld, it was dark outside, but I did some small test how it works, and it works quite well. Problem with the rocket stoves made out of steel is that the less efficient they are, they last longer, because the biggest enemy to steel is heat produced by rocket stove, and obviously that rocket stove has no isolation, so it cannot achieve the performance of the good quality rocket stoves. Yeah, but how I did it? Here is a burning chamber. Yeah, as you can see, I was also testing. I was not testing. I was training welds. From some of them, I'm pretty happy, but it's off topic. Now it has a steampunk look. So here we have a burning chamber with the extra slot for an air. For air. Air comes to the burning place already heated. Here we have this burning tunnel, and here it's a chimney, also called in books as a heat riser. Nothing is isolated, so yesterday I was able to achieve a little bit of blue flame, which means that we burn almost in a perfect conditions, but it was just a little bit of blue flame. Mostly it's a yellow. I will test it in a few minutes as well. I will record this not during the night, so maybe the quality will be better. But that's how. And by the way, that's the rocket stove batch box type. There are variations, but this is a batch box. So that's more or less how the rocket stove should be done. Many of the projects called rocket stove on the YouTube are another rocket stoves, and I'm not sure if my microphone will be able to record this, but the name of the rocket stoves comes from the sound making by the flames in this flame tunnel and some turbulence inside of this heat riser. So yeah, that's how it is. Nothing fancy, but it works. But that's all for now. Thanks for watching, and check out how it works. See you next time.